today I'm going to demonstrate how you can use messaging queues with SigNoz. So as you can see, I have a bunch of producer and consumer services writing to Kafka, and I probably have one more set of services which are Celery task workers. And I want to see, okay, how many messaging queues are there in my system. So you can come to messaging queue overview tab just by clicking at messaging queues. And you can see in my system, I have Kafka and Celery as two different messaging queues. We support all the messaging queues that are being instrumented by OpenTelemetry. All you need to do is instrument your producer and customer applications with OpenTelemetry. And you can see all the queues and the corresponding details right out of the box in this messaging queue overview. Now here I can see that there are some workers and Celery queue and the destination and a quick overview into error percentage, latency, and throughput. So if I just click on one of the row, I get details around what is the request rate, error rate, average latency. Basically, for that particular queue, what is the overall detail for that particular consumer, what is the request rate, what is the error percentage, and P99 latencies. If I click on any of the point, I can go to the corresponding traces belonging to that particular time interval. Let's see, we can also do filtering based on service name. We can do filtering based on the type of the producer and consumer. So if I just want to take a look at all the producers, or if I want to take a look at all the consumers, and we can also filter based on the messaging system. So if I want to take a look at Kafka, I can just quickly select that. And then we have a deeper integration into different messaging queues, starting with Kafka and Celery. So let's see what we can do with Kafka. So we provide different views and also what is happening at the ingestion. So our features are built on top of the OpenTelemetry semantic conventions, and we ensure that while you're ingesting your telemetry, if all the attributes are being there, if there's an error, you would see that error popping out here. Now, what I can do with the Kafka integration. So let's first understand what's there in the current products today. So today, all the products give you a panel view where you can see the broker, producer, and consumer metrics. And then you can understand what's the overall state of your messaging system just by looking at the metrics. But what is lacking in the current product is, for example, at a given time interval, I want to see there's a spike in my consumer group lag, and I can see that that spike is coming from consumer group 2, partition 2, and topic 2. But I don't know what producer and consumer services are responsible for that spike, right? And there's no easy way to dive deeper into the corresponding services, corresponding partitions, and corresponding topic. So for that, what I can do is just go to the consumer group lag view and okay, so let me select a time interval of, let's say, 6 hours. And I see there are a bunch of spikes happening at the consumer group lag for my Kafka. And if I want to take a look at a particular spike, I can zoom into it and then just click on the spike, and I'll get all the producer and consumer services which are writing to that particular consumer group topic and partition combination, which is contributing to the consumer group lag. And I can see, okay, these are the producer services which are writing to the consumer group topic and partition. What is the corresponding P99 error percentage and throughput? What all consumer services are consuming from that consumer group topic and partition split? What is the throughput? What is average message size? What is the network latency for individual service instances which are consuming from that Kafka, consumer group, topic, and partition? So this gives me an overview of, okay, if I see there's a spike, there are these producer services writing to it, these consumer services reading from it, and the corresponding network facilities. And that can help me understand, okay, if there's a spike, do I see auto-scaling happening for my consumer services? Or what is the reason for a spike? Is it because a lot of producer services are now writing at a higher rate? Maybe the throughput has increased, or maybe they're just scaling of producer services, right? So you can get that insight at a topic and partition level. So for a given consumer group, for a given topic and given partition, you would be able to understand if the consumer group lag is increasing, why exactly that's happening, and what are the producer and consumer services involved. And that can help in understanding, okay, do I need to fine tune how I'm configuring the producer services to write to a given partition? Do I need to tweak my partitioning key, or do I need to configure my topics, or do I need to figure out a better way to auto scale my consumer services? And also, what is the corresponding network latency? So this latency is today available as just a metric, but we do correlation between spans and metric to get that insight for topic and partition level, and that too at the service instance ID level. So you exactly know where the bottleneck is in your distributed Kafka systems, where there is like a lot of services producing and consuming from it, and you can dive deeper into a given consumer group flag. Similarly, there are other views where you can get an overview of different things. So for example, I want to understand for a given topic and partition, what is the P99 and throughput? So I can just click on it and see what all producer and consumer services are writing and reading from that particular topic and partition combination. It can again help me understand if I need to do some fine tuning of the configurations, or do I need to figure out a strategy for auto scaling of my consumer groups. In the producer latency view, we can see, okay, for a given topic, which services are writing to it, what is the corresponding byte rate, what is the partition level throughput. And then we have, if I go to the homepage, so this is the consumer group flag, producer latency view, partition latency view, and now let's take a look at drop rate view. So if I go to drop rate view, I can select the time interval, let's say for 1 hour, and the evaluation interval, say 10 milliseconds. How many messages took more than 10 milliseconds to process inside Kafka? So I can see for producer service 4, consumer service 3, there were in total 72 messages that were produced, out of which 5 messages took more than 10 milliseconds to process, and these are the corresponding trace IDs. Let's say if I increase this to 50 milliseconds, I would probably see less number of spans, because maybe most of my messages were processed in 50 milliseconds, and so on and so forth. You can navigate to the corresponding trace IDs. And yeah, so let's take a look at the final metric view. So this metric view gives an overall view of all the metrics that are being collected from your Kafka clusters. And you can just take a look at these metrics, understand the overall health of Kafka. But to be able to dive deeper into individual metrics and correlate that with producer and consumers, and understand what's happening at the topic and partition level, you can use different views like consumer group tag view, partition latency view to understand deeper into what's happening in Kafka. Also, it is supported out of the box. So if your applications are instrumented with OpenTelemetry, you do not need to do anything, and we would populate all the things out of the box. Now, as part of overall messaging queue integration, we also have Celery as integration, and it is an interesting one because all the LLM messaging systems, right? So today, LLM, like we are seeing a lot of our customers using LLMs, and this being natively written in Python, most of the applications are running Python, and Celery is a messaging queue which is written in Python, and a lot of LLM applications uses it. So that's why we have built this integration. Here you can see in the last 30 minutes, number of workers online, active task by worker, and what is the state of different tasks. So I can see, okay, these many tasks were in success state, these many tasks are in retry state. If I click on it, I can see the corresponding task and time them to complete it. We can then navigate from here to the traces. There is also P9, P95, P90 latency graph, where you can filter it by different task names. And if you click on it, you can see the corresponding traces just by navigating from here. And then we have different views like number of tasks executed by worker, error percentage by worker, and latency by worker. So if I go and maybe click here, I can see the corresponding task and the time it took for it to complete, and also what is the corresponding error percentage. So I can also filter by task name. So if I just want to take a look at a given task, I can filter that out and all the dashboards would be populated with it. So this gives them very quick overview of your Celery messaging queues. And with that, just try out our messaging queue features because it is supported for all the messaging queues, which are natively supported by OpenTelemetry. All you have to do is instrument your applications with OpenTelemetry and start using our messaging queues. Thank you.